Hello friends, welcome to lecture number 3 of chapter number 8, alternative fuels and exhaust emissions. In previous two lectures we discuss and study the alternative fuels, various alternative fuels and their suitability for SI engine as well as for CNG. So now in third lecture we are going to start the engine emission section, in which we are going to discuss various content of this exhaust emission, namely SI engine emission. It includes HC emission and CO emission and NOx, hydrocarbon emission, carbon monoxide emission, oxides of nitrogen. Then controlling methods, evaporative, thermal and catalytic converters. CI engine emissions, CO, NOx, smoke, particulate. Control methods for CI engine, chemical and EGR. And standard pollution norms, Bharat stage. Let's start with the engine emissions. 6. So as we know that the automobile plays important role in the transport system in all world, including India. So this rise in civilization is closely related with the improvements in transportations. So in the development of transport, the internal combustion engines, both petrol as well as diesel, plays important roles. It occupies the important positions. So petrol engine has provided reliable small power units for personalized transport, and in this way revolutionized the living habits of the people great extent. So diesel engine has provided power units for transportation systems, that is buses, good transportation systems like trucks. So indeed the petrol engine powered automobiles and diesel engine powered buses and trucks are symbols of our modern technological society. Modern technological society, these are the symbols, petrol engines and diesel engine. So in recent times the internal combustion engines powered vehicles have come under heavy attack due to various problems created by them. The most serious of these problems is air pollution. Most problem that due to this vehicle, that is air pollution. Whereas the main problem facing the developing countries in pollution, they are going to face the pollution, that is the engine pollution is important. So India however faces the same severe problem of pollutions in metropolitan cities like Delhi, Mumbai, Kolkata, Chennai, Kanpur. So likewise it going to faces the engine or these pollutions. So what is air pollution? What do you mean by air pollution? So air pollution can be defined as an addition to our atmosphere of any material which will have the deleterious effect on life upon our planets. So the main pollutants contributes by automobiles are carbon, that is carbon monoxides, unburned hydrocarbons and oxides of nitrogens, and lead and other particulate emissions. So again automobiles are not only the source of the air pollutions. Other sources such as electric power generating stations, industrial or domestic fuel consumption, refuse burning, industrial processing, they also contribute towards the environment, that contaminations. But however the percentage of air pollution from the automobiles is much more than the others. Because nowadays the increasing that automobile vehicles day by day, that is the increasing this number of vehicles is increasing, and in this manner there is a multiplication, there will be going to be occurs with the automobile vehicles emissions. So we will discuss these emissions from the vehicles, that is from gasoline engine or LPG or diesel, because again it is a petroleum hydrocarbon, that is a petroleum product, and again this petroleum products is contents of the hydrogen and carbons. Getting? So in gasoline as well as LPG as well as in diesel can found hydrogen and carbon, and that is the main sources for the emissions like hydrocarbons, carbon monoxide, oxide of nitrogen. So various engine design parameters are very important because it is directly influence on the emissions. So by proper design, by proper modification of these engine design parameters, one can control the emission. Getting? For example, engine compression ratio, air fuel ratio, then fuel rating, means octane number of that fuel, cetane number of fuel, combustion chamber design, turbulence, swirling motion, spark timing, advance, retard, fuel system design, means carburetor, fuel injection system design. Getting? Likewise, there are various engine design parameters are there by which control the emissions. So this figure will show you the pollutants from gasoline engine. This figure shows you the pollution from the gasoline engine. So there are four possible sources of automobile pollutions from petrol engine. Getting? Four possible sources are there from automobile engine. One, fuel tank, carburetor, crankcase and exhaust pipe. So the contribution of pollutants by these sources as shown in figure. So evaporation loss, that is due to the fuel tank and carburetor, it is up to 15 to 25% of total hydrocarbon emission. Evaporative loss from fuel tank and carburetor. Crankcase blowby from crankcase is around 20 to 35% of hydrocarbons, and tailpipe exhaust results 50 to 60% of hydrocarbons, and almost all CO and NOx. Almost all CO and NOx that will be observed in the tailpipe only, but HC will observe in fuel tank, carburetor as well as in the crankcase. Getting? So the evaporative losses, these are the direct losses of the raw gasoline from the fuel engine fuel system, that is carburetor. Getting? That is a carburetor. The blow by gas, that is the vapors and gases leaking into the crankcase from combustion chamber, and the pollutants from the exhaust pipes are due to the incomplete combustions. First, the emission from gasoline, evaporative loss. So evaporative emissions account for 15 to 25% of total hydrocarbon emissions from gasoline engine. The two main sources of evaporative emissions are fuel tank and the carburetor. Fuel tank losses, first we will discuss fuel tank losses. So fuel tank losses occur by displacement of vapor during filling of petrol tank. Fuel tank losses occur by displacement of vapor during filling of petrol tank, or by vaporization of fuel in the tank, forcing the vapor through the breather vent to the atmosphere. So where the temperature is low, where the temperature is low, fuel tank breathes in air. So air will be breathed by the fuel tank. So when temperature goes high, it breathes out air loaded with petrol vapor. When temperature is high, air breathes out. Temperature is low, air breathes in. So fuel tank losses occur because the tank temperature is increased. Fuel tank temperature increased during the vehicle operation. Getting? So because of that, fuel tank losses occurs with the increasing tank temperature increase during the vehicle operation, and which causes an increase in the vapor pressure and thermal expansion of tank vapor. Getting? So when the partially filled fuel tank is open to the atmosphere, partial pressure of vapor phase hydrocarbons and vapor pressure of the liquid are equal and they are equilibrium. Getting? So when fuel is partially filled and during that the vapor phase of hydrocarbons and vapor pressure of the liquid are equal and they are in equilibrium. If temperature of liquid is increased, getting, due to the engine operation, then vapor pressure of liquid will increases, getting, and therefore to restore the equilibrium, what happens? To restore the equilibrium, an additional liquid vaporizes and the total pressure of the tank increases. And since the tank is open to the atmosphere, the vapor will flow out of the tank, and this will cause the loss of the hydrocarbons. Getting? It will cause the emission of the hydrocarbons. Getting? So less the tank fill, greater the evaporation loss. Less the tank fill, greater the evaporation loss. Getting? So it will depends upon the tank fill. Getting? If 1/4 is there, then loss will be more. If 1/2 is there, loss is less. If 3/4 is there, loss is again less. If tank is full with the fuel, then loss is again negligible. Getting? So amount of fuel inside the fuel tank will also be very much important. Getting? So it will decides the how much loss of the hydrocarbons from the fuel tank. Then carburetor loss. Carburetor losses results from external venting of the float bowl, relieving the internal pressure as carburetor heats. And second, hot soak losses which occur after the engine has been stopped as a result of evaporation of petrol stored in the bowl, loss being through the vent pipe or through the air cleaner. So most of the loss from the carburetor occurs due to direct boiling of the fuel in the carburetor bowl during hot soak. Getting? During the hot soak. Then crankcase blowby. So the blowby is the phenomena of leakage. It is a phenomena of leakage past the piston, behind the piston, under the piston and piston rings, from the engine cylinder to the crankcase. So the blowby hydrocarbon emissions are around 20 to 35% of total HC emissions from the engine. Getting? So the mechanism of this leakage past the piston, getting, the mechanism of this leakage past the piston is due to the worn out of the piston rings. If piston rings are worn out, what happens? They are going to be goes into the crankcase. Air fuel mixture goes into the crankcase. Or if air fuel mixture is trapped in the top gland of the piston, in top gland clearance of the piston and behind the top ring, then what happens? Due to the quenching effect, it will not take part in the combustion and it will goes into the crankcase, and thereby it causes the crankcase blowby. Getting? Thereby it causes the crankcase blowby. Next, exhaust tailpipe emissions. So tailpipe exhaust emissions are the major source of automotive emissions. That is 50 to 60% of SC and almost all CO and HCH. Getting? So the tailpipe exhaust emissions are the major source of automobile emissions. Major source of automobile emissions. So here one by one we will discuss. First we will discuss the hydrocarbons. We will discuss the hydrocarbons. So hydrocarbons are produced because of incomplete fuel combustion or fuel vaporization. Getting? It will be due to the incomplete fuel combustion or fuel evaporation. It is closely related to many design and operating variables. It is related with the engine design variables as well as operating variables. Engine design variables are induction system design or combustion chamber design. Getting? Operating variables are air fuel ratio, speed, load. Getting? Air fuel ratio, speed, load. These are the operating variables. Maintenance is also important factor due to the for the hydrocarbon emission. Getting? So induction system determines air fuel ratio of the engine. Maintenance will include piston rings wear, lubrication, proper lubrication, proper cooling, deposits which are likely to affect the air fuel ratio supplied to the engine cylinder. Design of combustion chamber is also very important. In that, combustion portions which come in contact with the chamber walls quenched and don't burn. Some of this quenched fuel mixture forced during the exhaust stroke, and because of the high local concentration of hydrocarbons in the mixture contributes to high HC exhaust from the engine. So also this quench area opposes spreading of flame, causes HC emissions. Getting? So there are different reasons are there which will cause the incomplete combustions, and because of this incomplete combustion it will result in hydrocarbon emissions. So to avoid this, lower compression ratio, surface to volume ratio lower, high stroke to bore ratio is desirable. Hydrocarbon emissions is considered a hazardous form of air pollution because of it will result in eye irritation, throat irritation, lung irritation, is forced out of the chamber during the exhaust and possibility of cancer. High hydrocarbon emissions are result of cylinder misfire, improper ignition timing, worn cylinder rings, getting that will result in hydrocarbon emissions. So maintenance is also very important. CO emission. Next, that is a CO emissions. So carbon monoxide occurs only in engine exhaust. So it is a product of incomplete combustion due to insufficient amount of air in the air fuel mixture or insufficient time in the cycle for completion of combustion. So theoretically, gasoline engine exhaust can be made free of CO by operating it at air fuel ratio greater than 16:1, means at lean air fuel mixtures. Getting? So CO is always present in exhaust even at lean mixtures. Getting? But percentage is a less. Getting? So to avoid the CO emission, lean mixture is to be used. So the percentage of CO increases at ideal range. Getting? Percentage of CO increases when engine is idling, and it will reach minimum during acceleration and during normal cruising speed. During acceleration and normal cruising speed. Getting? So CO is again extremely toxic, colorless, odorless. It is a colorless, odorless and toxic. CO is rapidly absorbed by lungs and combines with hemoglobin in the blood, forming carboxy hemoglobin. Prevents blood cells from carrying oxygen to the body tissues. Adverse effect on brain nervous system as these have higher oxygen demand. High carbon monoxide emissions can be caused by restricted or dirty air cleaner, advanced ignition timing, clogged fuel injectors. This causes the high CO emissions. Then NOx emission. Next is the NOx emissions. So the factors which increases NOx will tend to improve the fuel mileage and lower HC and CO emissions. Getting? The factors which are favorable for NOx, that will be results to lower HC and CO emission as well as fuel economy. This means that to increase the fuel economy and lower HC and CO, production of NOx will be increased. Getting? And for this reason, emission controls have been added to lower all form of emissions. So here if you see the figure, the rich mixture HC increases, hydrocarbon emission increases for rich mixture. For NOx reduces. When mixture is lean, HC and CO decreases, NOx increases. Getting? So in this manner, factors favorable to decrease the HCCO, it is unfavorable for oxides of nitrogen or vice versa. So oxides of nitrogen which also occur only in engine, getting? It also occurs in engine exhaust. So oxides of nitrogen which also occur only in engine exhaust, they are again combination of nitric oxide NO and nitrogen oxide NO2. So nitrogen and oxygen react at relatively high temperature. So NOx is formed at high temperature, relatively high temperature. Therefore, high temperature and availability of oxygen are the two main reasons for the formation of NOx. Getting, if temperature is high and if the available oxygen is more or sufficient, then NOx emission will be occur inside the engine, or you can observe at the exhaust. Getting, so when proper amount of oxygen is available at higher peak combustion temperature, the more is the NOx formation. Getting, so the NOx is formed in the atmosphere as NO oxidizes. Getting, so inside the engine cylinder it is a NO. So when it is in atmosphere, it oxidizes because the oxides of nitrogen. Getting, so the combination of HC and NOx in the presence of sunlight at certain atmospheric conditions produces photochemical smoke. It produces the photochemical smoke. Getting, so again NOx is eye and respiratory irritant. It has irritating odor, smell, low solubility, reaches deep in lungs causing irritation, may produce mild irritation in upper respiratory tract. Asthmatic person may cause asthmatic attacks. Getting, so high compression ratio, lean air fuel mixture, hotter running engine produces more NOx than the earlier engine. Getting, than the earlier engine. So this is NOx emissions. Now let's discuss the CI emissions. So as we know that in SI engine the combustion occur, that is a homogeneous. Combustion is a homogeneous, whereas in diesel combustion is a heterogeneous. Combustion that will be occur, that is a heterogeneous. And because the diesel fuel is injected into cylinder filled with high temperature compressed air, emissions formed as a result of burning this heterogeneous air fuel mixture depend on prevailing conditions, not only during the combustion but also during the expansion, especially prior to the exhaust valve opening. So the mixture preparation during the delay period, fuel ignition quality, residence time, getting residence times at different combustion temperature, expansion duration, general engine design features play very important role in emission formation for CI engine. Getting, in emission formation of CI engine. Getting, so emission from diesel engines again classified in the same categories as those from the gasoline engines, but the level of emissions in these categories vary considerably. Getting, level of this emission will be considerably, it is a changes compared to the gasoline engine. Getting, so a sample of diesel exhaust may be free from smoke, odor and have no hydrocarbons, or it may be heavily smoke laden, highly odors, can be heavy concentration of unburned hydrocarbons. Getting, so the emissions again the same categories, but the will be more in case of CI engine. Getting, so again it will having the CO emission, HC emission with the NOx emissions, and again the same reasons is again applicable for the this hydrocarbon as well as for CO as well as for the oxides of nitrogen. Getting, then along with this HC, CO and NOx, it again causes the exhaust smoke. So again the smoke which is defined as a visible product of combustion due to the poor combustion. Getting, again the originates from the combustion only due to the rich fuel air mixture, due to the rich fuel air mixture or lean air fuel mixture. Getting so it will be again in the form of soot. If soot found sufficient oxygen, it will burn completely. If it not burn in compressor cycle, it will pass in the exhaust, and if insufficient quantity will be visible, then it is visible for the our eyes. Getting so again the smoke will be of two types: blue white smoke and black smoke. Getting so blue white smoke is caused by liquid droplets of lubricating oil or fuel oil while starting from cold due to lower surrounding temperature, and intermediate products of combustions don't burn. So this results in bluish or white smoke when exhausted. Also, when lubricating oil flows past rings, the results in blue white smoke. Blue white smoke other than cold starting indicates that piston rings are worn out and maintenance is required. Whereas black smoke is carbon particles suspended in the exhaust gas. It largely depends upon the air fuel ratio. Increases rapidly as load increase and the available air is less or depleted. Getting so again causes of smoke are various causes are there, namely injection system, fuel rating, maintenance, type of fuel, load, getting engine type, speed, fuel ratio. Various these factors are again responsible to generate, to create, to produce the exhaust smoke. Getting so one can control the smoke by proper maintenance, by proper additives, by proper exhaust system. One can reduce the smoke, one can control the smoke. Getting so now we'll discuss the soot and particulate matter. So as excessive use of fossil fuels is going to lead the global environment degradation effects such as greenhouse effect, acid rain, ozone depletion, climate change. Because of this excessive use of this fossil fuel, means petroleum fuels, which now results in greenhouse effect, acid rain, ozone depletion, climate change. Soot formation and particulate matter has traditionally been associated with diesel engines. Getting since the introduction of direct injection gasoline engines also suffer from this problem. It is not with the conventional SI engines, but direct injection SI engines, the problem of soot or particulate matter also arises. So upcoming emission standards will be introducing more stringent particulate matter regulations for gasoline engines. So again, soot is not clearly defined substance, but in general terms soot is solid substance consisting roughly 8 parts of carbon and have the highest hydrogen content with a carbon to hydrogen ratio as low as 1. But as soot matures, hydrogen fraction decreases. Soot is formed from unburned fuel which nucleates from vapor phase to solid phase in the fuel rich regions of carbon chamber at elevated temperature. Getting so particulate is combination of soot and other liquid or solid phase materials that are collected when exhaust gases pass through the filter. Particulate is often separated into soluble or dry fraction. So the fraction of soot in particulate from diesel exhaust varies, but is typically higher than 50%. Other particulate matter constituents include impartially burned fuel, lubricating oil, bound water, wear metals, fuel derived sulfate. It again the main constituent